Hi Shu, hi Jess.
Hello Visha, hello Jess.
What should we study today? Jess? Shu?
I'm currently studying mathematics. The question is so confusing.
If you don't mind, may I know which topic you are struggling with?
The method of integration by partial fraction.
Oh, I can help you with that. Just in return, I hope both of you can explain to me integration by part and also trigo substitution because I have kind of some problem with those two topics.
I can help you with trigonometric substitution.
Oh, and I can help you with integration by parts. Okay, so give me the question. For question 1a, it is integration t4 ln t dt. So, the first thing that we need to remember in integration by parts is like L for log expression, I inverse, A algebraic expression, T trigo, and E exponential. Okay, this will determine which of our equation will become our U. So ln is log, so our U will become ln T, and automatically T4 will become our dV. Okay, next we got our U. U ln T, we need to find our du. So first, we are going to differentiate our ln t will become 1 over t. And we make du the subject, which will become 1 over t dt. Okay, now we will move on our dv. From our dv, we will find our v. Okay, so to find our dv, it's easy. We just need to integrate t4, which we will get t5 over 5. Now, with all of our v, dv, and du, we are going to make the equation uv minus integrate v du. Now, we put in all our equations. We will get ln t multiplied with t5 over 5 minus integrate t5 over 5 multiplied with 1 over t dt. Now, we will simplify this and we will get ln t multiplied with t5 over 5 minus integrate t4 over 5 dt. Why we will get integrate t4 over 5 is because t5 over 5 multiplied with 1 over t, we will cut the t and the power of 5 will become 4. Now, we will need to simplify integrate t4 over 5 even further. Okay, we will take out 1 over 5, which will become 1 over 5 integrate t4 dt. Now, we will integrate t4 and we will get t5 over 5 plus c. Now, we will bring all our equation together. We will get ln t multiplied with t5 over 5 minus t5 over 25 plus c. And that is with our question 1a. We will move on to the next question, which is 1b. Okay, the question is a little bit more complicated. It is integration 0 to pi over 3 sin x ln cos x dx. Okay, we must think simply. First, we identify which is which. Okay, sin x is t trigo and ln cos x is log. And from that, we know that our u is ln cos x. Now, here comes the tricky part. We must integrate ln cos x, which will become negative tan x. Why? I will show you. dy dx ln cos x, we will get 1 over cos x d dx cos x. This is because it is a function in a function. So, we will get 1 over cos x in the bracket negative sin x, which will become negative sin x over cos x. Sin x over cos x is tan x. With the negative, it will become negative tan x. That is our du dx. Now, we will make our du the subject, which will become negative tan x dx. Okay, we'll go back to our dv, which is sin x. So, integrate sin x, easy. We will get negative cos x, which is our v. Now, we substitute into the equation uv minus integrate v du, which will become ln cos x multiplied with negative cos x minus integrate cos x multiplied with negative tan x dx. Now, we simplify everything. Negative cos x multiplied with negative tan x will become sin x, and it will become integrate sin x dx. Now, we will get our final equation will become negative ln cos x multiplied with cos x plus cos x integrate from 0 to pi over 3. Now, we can solve this equation and substitute the 0 and pi 3. We substitute everything, we will get 0.999 minus 1. And the final answer is negative 3.34 minus the multiply with 10 to the power of negative 4. That is our final answer. Now that we have done all the questions, what about we do some past year questions? Okay, the question that we have chosen today is June 2018, question 3. Now, okay, I choose to answer question 3a, which is an integration by parts question. So, the question is integrate x squared ln x dx. From this question, we can see some very real familiarity with the first question that we answered. So, remember Layat, x squared is a, ln x is l. Thus, we know that our u is ln x. Okay, so d over dx, so we need to integrate ln x, du over dx equal to 1 over x. Easy. Now make du the subject, which is 1 over x dx. Now we go back, our dv, which is dv equal to x squared. So integrate x squared to find the v. We will have x3 over 3. Now we have all our parts. Put into our equation uv minus integrate v du. Okay, we will get ln x multiply with x3 over 3 minus x3 over 3 multiply with 1 over x dx. Okay, we can simplify it a little bit more, which we will have ln x multiplied with x3 over 3 minus with 1 over 3 integrate x squared dx. Now, we solve our integration, which we will have x3 over 3 plus c. Our final equation will become ln x multiplied with x3 over 3 minus x3 over 9 plus c. Now that is our final equation.
Okay, so let us proceed to the question that involves trigonometric substitution. So our question here states to evaluate the integration of 1 over x squared square root of 4 minus x squared dx using trigonometric substitution of 2 sine theta. So the first step is we know that we have to substitute x with 2 sine theta. So x equals to 2 sine theta. And then for the second step, we will have to differentiate the x equation. So dx over d theta equals to 2 cos theta. Because differentiating sine theta, we will get cos theta, and the constant of 2, it will remain the same. So from this differentiation, we can get dx to be 2 cos theta d theta. And in the next step, which is the third step, is we have to draw a right angle triangle. And after that, to find the respective parts, respective sides of the right angle triangle, we can use the first equation that we have previously wrote down, which is dx equals to 2 sine theta. And by letting the sine theta to become the subject, it is equivalent to x over 2. And we know that sine theta is equals to the opposite over the hypotenuse of the right angle triangle, so the numerator part of the fraction will become the opposite and the denominator part will become the hypotenuse. So in this case, x will be the opposite side of the right angle triangle, and the value of 2 will become the hypotenuse side of the right angle triangle. And then next, to find the adjacent side of the right angle triangle, we can use the Pythagoras theorem. in which that Jeslyn will be equals to the square root of hypotenuse squared minus the square root of the opposite, so we will get square root of 4 minus x squared. Next step, which is the fourth step, is we need to simplify the square root or any x squared given in the question. And by referring the question, yes, there is a x squared and also a square root in the denominator part of the fraction. So we'll take that out. X squared square root of 4 minus x squared will be equals to, and then substitute the x with 2 sine theta, so we'll get 2 sine theta squared, square root of 4 minus 2 sine theta squared. So we can expand this, expand to become 4 sine squared theta, square root of 4 minus 4 sine squared theta, and then we can actually factorize the equation inside of the square root. We'll get 4 sine squared theta, square root of 4, 1 minus sine squared theta, and by using the Pythagorean identity of sine squared theta plus cos squared theta equals to 1, and by getting the 1 minus sine squared theta to become the subject, it is actually equivalent to cos squared theta, so substitute the 1 minus sine squared theta to be cos squared theta, and then after that we can simplify it to be 2 cos theta, because the square root of 4 will become 2 and the square root of cos theta will be just cos theta. So it will be 4 sine squared theta, 2 cos theta, and then after simplifying it, we will get 8. So the fifth step is we have to substitute the x to be the theta. So integrate 1 over x squared, square root of 4 minus x squared dx equals to integrate 1 over. So this denominator part right here, we will take the reverse simplification that we have done in the previous step. So it will be at 8 sine squared theta cos theta, and then the dx will be 2 cos theta d theta, as we have done in the previous differentiation in the second step. And then we can simplify this. Cos can be cancelled out with cos, and then everything we simplify to become 4. So we'll get 1 over, integrate 1 over 4 sine squared theta d theta, and then take the constant out, 1 over 4, integrate 1 over sine squared theta d theta, and then 1 over 4. You can actually simplify, you can actually factorize the 1 over sine squared theta to become 1 over sine theta, and then square outside of the bracket d theta, and then we know that 1 over sine theta is equals to cosecant theta, so substitute that 1 over 4, integrate cosecant squared theta, don't forget the square because there's a square outside of the bracket, d theta, and then integrate cosecant squared theta, we will get negative cotangent theta. So 1 over 4 negative cotangent theta plus c. We have to put the constant c because there is no limit. So negative 1 over 4 cotangent theta plus c. For the last step in this question, we'll have to substitute back the theta to become x. So negative 1 over 4 cotangent theta plus c. So for this, we know that cotangent theta is actually equals to 1 over tangent theta. And by referring to our right angle triangle that we have drawn previously, we know that tangent theta is equals to the opposite over the adjacent side of the triangle, so it will be x over square root of 4 minus x squared, but it is 1 over tangent theta due to cotangent theta, so we'll get square root of 4 minus x squared over x. So substitute that in, so it will be negative 1 over 4 square root 4 over x squared over x plus c. So simplify this equation, we will get square root negative square root 4 minus x squared over 4x plus c. Now let's look at the past year questions that involve trigonometric substitution. So the question states to use trigonometric substitution x equals to 3 sine theta to evaluate integration of 1 over x squared square root 9 minus x squared dx. So let us write the given equation here. We know that we have to substitute x equals to 3 sine theta. And the next step is we have to differentiate the x equation. So dx over d theta will be 3 cos theta, because differentiate sine theta will get cos theta, and the constant of 3 will remain the same. And we will get dx to be 3 cos theta d theta. And the next step is we have to draw a right angle triangle, and to find the respective sides of the triangle, we can use the first equation that we got. In the first step, that is x minus x equals to 3 sine theta, and by letting sine theta to become the subject, we will get x over 3, and then the numerator part. The numerator part of the fraction will become the opposite side of the triangle, and the hypotenuse part, which is the denominator part, which is the value of 3, will become the hypotenuse side of the triangle. And to find adjacent, we can use the Pythagoras theorem formula, where the adjacent will be the square root of hypotenuse squared minus the square root of the opposite, so we will get adjacent to be square root of 9 minus x squared. So our next step, which is the fourth step, is we need to simplify the square root or the x squared if present in the questions. So referring to the question, there is an x squared and also a square root. So in the denominator part, so we need to simplify that. So take out the denominator, x squared square root 9 minus x squared, and then substitute the x, we will get 3 sine theta squared square root of 9 minus 3 sine theta squared. So again, expand the equation, we will get 9 squared theta square root of 9 minus 9 sine squared theta, and then we can actually factorize the equation inside of the square root, so we will get 9 sine squared theta square root of 9 1 minus sine squared theta. And then by referring to the Pythagorean identity of sine squared theta plus cos squared theta equals to 1, and by letting the 1 minus sine squared theta to become the subject, it is equivalent to cos squared theta. So substitute the 1 minus sine squared theta to be cos squared theta. So we get 9 sine squared theta square root of 9 cos squared theta. And then to simplify this equation, we will get the square root of 9 to become 3, and the square root of cos squared will become just cos. So we write that 9 sine squared theta 3 cos theta, and then for the simplification, we will get 27 sine squared theta cos theta. So for the fifth step, the next step is we have to substitute x with theta. So to do that, we will need the integration of 1 over x squared square root of 9 minus x squared dx equals to integration of 1 over, so the denominator part, we will take the previous simplification of the equation that we have done. So it will be 1 over 27 sine squared theta cos theta, and then the dx will be 3 cos theta d theta from the previous differentiation that we have done in the second step. And then simplify this equation, we will get we can cancel out cos with cos, and then cancel out simplify, so the 7 with 3 will get 9. So everything integrate 1 over 9 sine squared theta d theta, and then take the constant out, which is 1 over 9, integrate 1 over sine squared theta d theta, and then 1 over 9 integrate, you can actually raise out the squared, so there will be 1 over sine theta squared, in which the square will be outside of the bracket d theta, and then 1 over 9 integrate because we know that 1 over sine theta is equals to cosecant. So integrate cosecant squared. Don't forget the square because there is a square in the outside of the bracket. So cosecant squared theta d theta, and then integrate cosecant squared theta, we will get negative cotangent theta. So 1 over 9 negative cotangent theta plus c. Put the constant of c because this is an indefinite integral. So equals to 1 over 9 cotangent theta plus c. So for the next step, in which we have to substitute back the theta to become x. So take the previous equation, negative 1 over 9 cotangent theta plus c. And then to substitute this cotangent theta, we have to refer the right angle triangle that we have drawn previously. So cotangent theta equals to 1 over tangent theta. So tangent theta equals to x over square root of 9 over x squared. But because this is a cotangent, so 1 over tangent theta equals to square root of 9 minus x squared over x. So substitute that back in, so it will be negative 1 over 9 square root of 9 minus x squared over x plus c. And then simplify this, we will get negative square root of 9 minus x squared over.
Wow, thank you, Jess. Thank you, Shu. So I think it's my turn to explain about the question number 3 regarding partial fraction. So basically, firstly we need to know the partial fraction is basically decomposition that only works for the proper rational expression. Therefore, we need to make sure that the degree of numerator is lesser than the degree of the denominator. Okay, so we can see here in the question the rational expression of 10x power of 2 minus x plus 15 over 2x minus 1 x power of 2 plus 4 is basically, we can clearly see that the degree of the denominator is bigger than the numerator. Thus we can actually straight away refer to the list of the formula to quickly write the integrand as a sum of proper rational function. So it's going to be a over 2x minus 1 plus bx plus c over x power of 2 plus 4. Okay, and then we need to cross multiply them because with this we can actually compare the nominator part of the expression with the question again. Okay, so we are going to get 10x the power of 2 minus x plus 15 equal to a in bracket x power of 2 plus 4 close bracket plus b open bracket 2x power of 2 minus x close bracket plus c open bracket 2x plus 1 close bracket. Okay, now after we got this one, we are going to find the value of a, b, and c by substitution method, which is if you can see clearly here, from the denominator back up here, we can get actually the value of x. We are going to substitute into the equation of the tan x plus 2 minus x plus 15 equal to a something, this one, the long one. Okay, so from this denominator we can found that 2x minus 1 equal to 0. Okay, so we can find that x equal to 1 over 2. This is the first x. And then we have x power of 2 plus 4 equal to 0. Okay, this one we are just going to use calculator. If you press the calculator, it's going to be x equal to negative 2 and also x equal to 2. Okay, this value of x we got, we are going to substitute into this equation. Okay, how? Okay, we are going to start this like this. Okay, firstly we are going to start like this. When x equal to 1 over 2, okay, we just stop into it. Okay, and then we are going to calculate. Okay, now we got a equal to 4. Okay, next we are going to write x when x equal to -2. Okay, sub into the equation again. And then now we got, okay, we cannot actually got any value, but we can we cannot like, you know, solve it right now, but then we are going to proceed when x equal to 2. Okay, okay, see, now we got 21 equal to 68 plus 3c, right? Now make it c as the subject. Okay, from here we got c equal to 7 minus 2b, right? So here we are going to substitute the value, this c equal to 7 minus 3b back into this second equation. Okay, by then we are going to get the value of b. So basically the value of b is equal to 3, and then when we got the value of b, okay, then we just substitute lah the value of b inside this equation again, and then we got the value of c equal to 1. Okay, now what we're going to do with all these a, b, c values, we are going to substitute them back and start to integrate. Okay, so we are going to substitute back, and it's going to be integrate 4 over 2x minus 1 plus 3x plus 1 over x power of 2 plus 4 dx. So now we can clearly see here we got like basically an equation we can solve. So firstly we are going to put the 4 outside, and then okay, for this expression we can basically separate them. Okay, we are going to separate them into this, integrate tx over x power of 2 plus 4 dx plus integrate 1 over x power of 2 plus 4 dx. Okay, so we can see here there are 3 different integration. So here we are going to solve it one by one to make it easy for us to find the value. So basically for the first one, we are going to integrate by using logarithmic function, where when we integrate okay, so when we integrate 1 over 2x minus 1, it's going to be 4 times 1 over 2 is basically we differentiate the denominator, 2x minus 1, we got 1 over 2 integrate right and then ln in bracket 2x minus 1 plus c. This is what we got. Okay, then the second one we are going to integrate 3x over x power of 2 plus 4. So this one is kind of complex, so we are going to use substitution method where u equal to x power of 2 plus 4. So we are going to integrate, we are going to differentiate u, which is u are going to be du over dx equal to 2x, and then we are going to make the dx as a subject. So it's going to be du over 2x equal to dx. Okay, and then we are going to substitute x inside the equation, back then the expression, which is integrate 3 over u du over 2x. Okay, basically the x at the denominator and also at the 2x, we are going to cross the x, and now it's going to be integrate of 3 over u du. So basically we got integrate 3 over u du over 2. So basically 3 and 2 we can put it outside, we can factor out, so it's going to be 3 over 2 integrate 1 over u. So now 1 over u, right? Now, so basically we can use logarithmic function and it's going to be 3 over 2 ln in bracket u. Now we just substitute back the value of u. It's going to be 3 over 2 ln x power of 2 plus 4. That's it. That's it. And then lastly, we are going to integrate this one, which is integration of 1 over x power of 2 plus 4 dx. Okay. If we look at it very properly for this one, we can properly see that this is actually integration of inverse trigonometric function. Okay, so where is going to be integrate 1 over x power of 2 plus 2 to the power of 2. Now we can clearly see, right, the value of a and the value of a. So it's going to be 1 over 2 tan negative 1 in bracket x over 2 close bracket plus c. Now we can just combine all of them and it will be 2 ln in bracket 2x minus 1 close bracket plus 3 over 2 ln open bracket x power of 2 plus 4 close bracket plus 1 over 2 tan negative 1 open bracket s over 2 close bracket plus c. Therefore, that's the final answer. Okay, so basically same goes to the puzzle question, because if we look at the question very properly, we can see that the degree of the denominator is basically bigger than the numerator. Okay, therefore, the integral as a sum of proper rational function, we can just look at the list, which is a over x plus 1 plus b over 2x minus 3. So from here, we are going to cross multiply them. Actually, for us to compare the numerator part easily, to find the value of a and b. Okay, now we got a 2x minus 3 plus b x plus 1 over x plus 1 in bracket 2x plus 3. Okay, from here, if we look at the denominator part, we can actually find the value of x, so we can use it for substitution method to get the value of a and b. So we are going to rewrite all the numerator from the question and also what we got here. So it's basically 2x plus 1 equal to a in bracket 2x plus minus 3 plus b x plus 1. So we can clearly see that when the value of x that we got just now is x plus 1 equal to 0. So x equals to minus 1. Also 2x plus 3 equal to 0. X is going to be 3 over 2. So they are going to substitute the value of x negative 1. So when x equal to negative 1, we substitute and we got is basically a equal to 1 over 5. And then we are going to proceed with the when x equal to 3 over 2. When we substitute, we are going to get the value of b equal to x or 8 over 5. Okay, so when we got the value of a and b, we are going to substitute back in the value of a and b from what we got from the proper rational function just now, the integral of the sum of the proper rational function. So what we got is integrate 1 over 5 the value of a over x plus 1 plus is 8 over 5 over 2x minus 3 dx. Okay, from here we can actually see that we are going to factorize out 1 over 5 out. So we got 1 over 5 integrate 1 over x plus 1 dx, plus we also are going to factorize 8 over 5 out. So 8 over 5 integrate 1 over 2x minus 3 dx. Okay, for the first part, which is 1 over 5 integrate 1 over x plus 1 dx, we can actually see that we can use the integration of logarithmic function. So you can just straight away say it's going to be 1 over 5 ln x plus 1 cross bracket plus c. Okay, and the next one is the next part. We can also use the integration of logarithmic function again, and then we got 8 over 5 times with 1 over 2. 1 over 2 is basically what we got when we integrate to x plus 3, a minus 3, and then times with 8 ln 2x minus 3, and then we got the value, which is when we solve, we got 8 over 10 ln 2x minus 3, and then we just simplify 4 over 5 ln 2x minus 3 plus t. And then both sides, we are going to just rewrite it again. It's going to be equal to 1 over 5 ln x plus 1 plus 4 over 5 ln 2x minus 3 plus t. So that's the last answer.
Wow, thank you, Shaishu. It looks easier now.
Thank you, everyone.
Yay! Thank you, everyone. We should do this kind of discussion again later.
Yes, sure. Bye everyone. See you again.
Bye. Bye-bye.
Bye.